Hello, welcome to toddfun.com. I'm in the middle of upgrading my workbench. This is the normal workbench you see behind me in my blog videos. I needed more shelves and more power strips for all my equipment so I could quit stacking all my junk and sharing. I used to share one single outlet. There used to be one outlet there and I'd share all my equipment off of it, which I know was silly, but I was just putting this off. So I'm going to have, there's a shelf going to be at the bottom, 1, 2, 3, 4 shelves. There's room for more if I want other stuff higher up. And there's going to be, coming out here, that's just going to be a cover plate just to cover where the power used to come. And I've routed over the power over to here so that the shelving won't cover the switch for the power and the lighting. So what we have coming in here is, this is the power coming in from outside, and that was always there, and this was always there. This goes to the lighting overhead. Then it actually brings power over to here, and here it's going to be the GFI is going to be on this side like it always was, and that means everything will be GFI after that. There'll be GFI coming up to both of these rails. There's 10 outlets will be across there. This is just the back framing and the piping. And then I'll have another 10 outlets going across that one down there. And then this is going to be a switch over here for turning power to the overhead lights and this pre-existing power strip I have. That way I don't have to turn on my workbench over here in order to just have lighting and power at my workbench. So I can have the electronics bench on separate from the tool bench over here, and that will both be a single switch here, and then there'll be another switch right beside the GFI that turns on just these power strips for the for all the equipment. Now granted, I can't have it all running at one time, I mean we all know that, but at least I don't have to fight plugging it in every time I need a piece of equipment. Let's see, I originally had this for many years, and this is just a power strip with an existing outlet cord. And this is pretty easy to run, and then you put a little clamp, you put one of these clamps on there, and then you cut the wire, you cut the plug off, and then you wire it up. But that's expensive. These are a lot more expensive than these, which are, they just have wires coming out of them, but they're the same thing. They're just the same 10 outlets. They just you gotta wire up the power yourself. But they're pretty easy. You just bend them over on the one side, you mount the back strip on your wall, and then you terminate. You can actually daisy chain these, but I just terminated them with some wire nuts. And I recommend marking where these, you line it up first, and you mark where these are going to be with X's. And you want to avoid putting screws where these X's are, because then there won't be any room for this back plastic piece to snap in to this rail. So that's a little trick you want to probably keep in mind. And so I went with a plastic conduit because I'm pretty handy at using it. You'll notice I have conduit going up the wall over there and going across. There's straps every so often. Comes down, provides power for my compressor and GFI outlet over there. Goes back up. There's a switch. Goes to all of those T8s over there. I think there's there's 8, 9, 10, 11, 12 T8s, and that makes for working on your car. Basically it just surrounds your whole vehicle with light so you can work on engines and stuff. But I'm going to put the same thing on this side, which you see over here. I just have some really bad hanging T12s. They're really noisy and really dim. So this side's going to get a lot brighter here when it's all wired into that switch there. And this would have been okay for running some power, but these are so much more expensive. These are like $34, and these are, oh man, they were tremendously expensive. And there's nothing different. You still got to take them apart and mount them, so you're not really saving anything with that. I would say it's just cheaper to do it this way, but then you have to come up with some sort of wiring. And this stuff is really kind of cheap. These elbows, you buy these elbows with the flares, or you buy the straight pieces with the flares. This elbow will run you about I don't know, less than $1. And a 10-foot piece of pipe like this runs at less than $2. It's 10 foot of that with flare on one end. I recommend then buying these are the clamps to hold it on the wall. Granted, I don't need clamps here because it's so short. But if you do longer runs, you want to buy a bag of clamps. It's less than $2 for all these clamps. It's about $5 for this kit, and these are in case you have wall board, and these are the screws to put on these clamps. So another, less than another $8, and you got your clamping. You do have to then have these couplers to go into things. They're about 25 cents a piece, but if you buy a bag of 15, it's less than $2. And then these are just the tighteners. Once again, a couple bucks buys you about 20 of those. I was trying to find one more thing. I recommend for another couple bucks you get 15 of these, and they're just couplers. They're just straight couplers. That just puts, so you basically have two pieces of pipe that aren't flared, and you can couple them together. It's a little harder to pull the wire when you do that because the wire can get hung up on these bits. So if at all possible, plan your install so that you're always going with your wire from your source, and then actually in this case you would want to come from this side as your source, come this way, and you won't catch on this type of sleeve. And all the pieces of pipe will come with one side sleeved, and you can buy little sections of this that are sleeved, like this curve is sleeved on this side. And that makes fishing your wire through smooth, and nothing can get hung up. If you use these in an emergency spot, it's a good place you can get hung up on. But it works. But of course then you got to run your own wire. I mean, there's no wire in any of this. Unlike, well, I mean, you don't want something like this. You don't want something like that just running down your wall. This is just it's hard to say, Molex, I think they call it. And this is yellow because it's for 20 amp. But you could use armored cable. Armored cable is really decent. It's easy to work with. It's easy to fish it around. But it's expensive. Armored cable is expensive. This stuff is really cheap. Like I say, $2 for a 10 foot of this, and a couple bucks for these when you need them. And really, that armored cable can run a lot of money. And you got flexibility. If I want to run 1 wire, 2 wire, 3 wire, 4 wire, 5 wires, I just pick and choose what I need. But then you do have to have the wire. And many years ago, probably 10 years ago, I bought 3 500-foot spools. They were expensive, but man, I've done a lot of installs. I've done outdoor wiring, I've done wiring in other people's houses, I've done my garage several different ways, and look, I still got all this left. Now this is 12 gauge. Upside down. This is a 500-foot 12 gauge stranded. Now you might say, hey, stranded, that's not right. Well, maybe it's a little difficult to work with, but when you have to pull this stuff through, the stranded stuff pulls and bends a lot easier. You don't have to fight so much to move it around through your conduit. But, you know, you don't really have to have it. And it's just, to me, 12 gauge stranded is easier to pull around, and it's still a lot of copper there to handle big loads. You'll be fine. But solid would work too. And then for connecting them all, as you see, I have this little demonstration pigtail here. I do have stranded, and these are pretty slick. They just push on. You just basically strip some wire back, and you just push this together. And then you can put, this one can take 4 together, and you don't have to use wire nuts. You know, saves a lot of space in your junction boxes. Here's a 2-piece here, 3-piece here. Buy several bags of these. They come in real handy. I've been using them a lot lately. I haven't had any problems with these. These are, you know, and you can actually take them apart too. There's a little slot right there. You stick something in there and jam real hard, and you can pull your wires back out again. And yeah, the stranded does go in here. Don't fuss with it much. Just strip it and stab it, and it goes right in. And so stranded works with this too. You just got to be a little more careful. Give yourself a little extra wire in case you have to start over. But it does work. And so then I'll be pulling some of this wire through. I got 3 different colors here, of course. All I have to do is pull some wires through now, snap on my outlet rails, put in some switches. This is just going to be a cover plate over here just to cover this old spot that used to have stuff. And then I'll have my switches in, and everything will be GFI protected, and I will no longer have to fuss to turn my equipment on. And this would be a normal type of box you would use when you're using the plastic conduit like that. You would use a box like this instead. I just didn't want to do it this time. I've done it many times before. It wasn't liking the solution, mostly because I wanted to have a three-way here, and this was a little easier to get these three things together tighter. And I knew that I had to have one of them had to have that clamp, and that would of course not work too well with this. And I'd have to come up with something to get it in there. And I had all this stuff laying around. I had most everything that fit these boxes, and this was the old box anyway. And I had the covers, and so I just figured, it's no big deal. These work just the same. They screw into these will screw into these boxes just the same as these boxes. So yeah, I just went with the steel boxes. Okay, a little update here. I put in two undershelf fluorescents. They're both 21-inch fluorescent bulbs. They actually daisy chain together, and then they'll get power over there. They'll come on at the same time this power rail comes on at the bottom one, which is all the power rails here. As you can see, I have all of the wiring pulled, going through, and the proper wires going every which direction so that everything can be wired up once I get the switches and outlets in. It's going to be kind of tight in this box, but I knew that when I started. And what I had gotten, if I can grab it here, is I made sure I bought a really deep box because I knew this was going to be a lot in here. And I got this cover plate that's got some thickness to it as well. I had originally thought I was going to just come out of here. I basically bring the power over to here and then come down and then just power this rail, turn around, come up into this rail, power that rail, turn around, come up into this rail, and just keep on going, because even though I can have a lot of equipment plugged in, it wouldn't all be on at one time. Two things came into play. One, these junction boxes here, they are about $5 a piece, and they do not come with this. You have to buy them separately. And they're kind of a fuss. Once you cover it up, even 3 wires in here, hooking up 3 wires in there is quite tight. And at the very end, if you notice, the first one, once I would have a junction box right about here, there's no possible way of turning. I would have to come out of the junction box straight up, which is doable. Those junction boxes do that. You wouldn't turn at all, you just go straight up. You can see there's a knockout here. As long as I kept them in line, I could have easily just went straight up without a turnaround problem. But you still have that $10 added cost. By putting it all over here, I don't have that added $10. Okay, everything's actually wired up. I have not put the cover plates on because I have not tested it yet. What was important in this box is that because this is a GFI outlet, all these outlets, every single outlet, even these extra ones down over here, the original ones that were there, all of them have to be on the load side. Both the common and the power, common and hot, have to be on the load side of that GFI. The GFI only gets power from over there, that was fairly important. I do now realize that even though it would have cost more money to buy 2 more of these and then do the series thing, it would have looked cleaner because I wouldn't have these 2 pipes here. You literally would come over here and go straight from this one to this one and then terminate it at the other end, and that would look a lot cleaner. Plus it would have reduced the wiring in here. It wouldn't have really changed the functionality of anything. So I think if I were to do this again, I would definitely pay the extra $10 and have a less of a wiring rat nest over here. So now it's time to test. I haven't turned the power on, so I'm going to go out and turn the power on, come back, and we'll test the power and the GFI. Power's on, and the circuit didn't break, so that must mean I don't have any major problems. We'll start with the with this switch over here, which is going to be to power this bench side electrical, and yes, it is on the GFI, as well as it turns on the overhead lighting. When I flip the switch, the overhead lighting should come on, and this GFI tester, the two yellow lights should light. So here we go. Aha! We have light! And yes, we have two green light, or two I guess you call them yellow or amber lights. That checks for good. That GFI is good. This will actually trip the GFI. So this is to prove that this is a GFI outlet. If I push this button, we should get a trip. Yep, and we did. And that was this guy tripping out because of that test. So we can just reset that. And yep, it's all back on. So now we can come over to this side and we can do the same test over here. Right now this is off because I don't have the power switch on right here for all of my 32 outlets. Well, actually these are hot all the time, so 30 outlets. I flip this, no lighting, well, no lighting, these lights aren't going to come on because they're not plugged in, but I guess I could plug them in as another test. They're going to essentially be plugged in all the time right there. And so I will have the bench under shelf lighting come on when my 30 outlets come on. So let's test this. Aha! That comes on. Nothing happened. We come over here. Yes, we do have two amber lights. It'd be easier to see that if I turn that off. We have two amber lights. That means that GFI checks and a GFI trip. I guess would be just like this. Boom. And we had a GFI trip. And now we can turn back on. And everything's on again. We just have to button it all up. I got to get all these wires back in there, but I'm going to go turn off the power again before I try that. And then I'll test it one more time, and I'm going to call it good. So that's all buttoned up. It's nice and deep. As I told you, it was a deep box with this deeper cover, and so it was really easy to get everything in there. It really wasn't a trouble at all. And these have to get covered. There's 3 of those, but they're easy, one screw. And this is where the original supply was, but this goes up to the light, and this is the in power. And now that all wires up to that. I basically got moved the power. Can't do this with the holy. So that'll just go on like that. I don't want anything here. It's hard to reach anyway because a big shelf comes out. So that's just to button that up. Well, we'll finish that up and then go turn the power on. Okay, there's the final project. I got my 4 shelves and my wiring and 32 outlets. It's a little dark in here now because I haven't switched on the lights. You can see this is indicating a pass on the wiring. I wanted to test the GFI for here too, so we'll push the GFI tester right here. And bingo! We do have good GFI. And that's good, so we're good to go there. Flip on the light, the power over at the bench and the lights, and that's good. And now this switch will be for all the power at the electronics bench, as well as the under lighting here as well. My lights didn't come on. Why did my under shelf lighting not come on? We have an issue. We have no power down here. We have a problem now. We're showing a problem now. If you see, we're showing a problem over here. So we got this hot ground reverse. But it's not true. It wasn't true when we tested it earlier. It's good right now, but when I flip the power for the overhead lighting, then it shows bad. Okay, I did something stupid. Back to the drawing board. I mean, that's not coming on at all. Well, I was all hip about using these quick snap-ons. I have used them in lighting a lot and never had a problem. This is my first time of trying to use these in outlets. Maybe I will regret this decision yet. But if you see right there, that guy is not hooked up anymore. Well, it was hooked up. It was hooked up to this guy. And it has managed to slide right out of there. When I was roughing up the wires, pushing them in, it managed to slide its butt right out of there. And that is causing the discombobulation with our tester here. So I am going to double check all these and make sure they're all tight, and one more shot at using these, otherwise I'm going to have to switch over to old-fashioned wire nuts. Okay, I double checked that. I jammed it in there real good, trimmed it a little bit and jammed it into that connector. Double checked all the connectors. They were all as deep as they could go in each one of those. They were all super tight. None of them looked like they were going to possibly pull out. I'm thinking maybe I didn't jam it in tight to start with. When I was just setting it up, I must have just not given it a good jam, and it must not have seated in it, because it's just not likely that those are going to pull out that easy. So here we go. Let's go. Let's start test our overhead lighting. That's good. And we're good down here. And we should still be good here. Yep. Now we'll turn these on. And then this should still be good. Yes, it is. This should be good still. Yes, it is. Now this one should be good. Yes, it is checking good now. It's no longer got that wire grounding out inside the box. And we should still be tripping. Yes, they're still good there. Yep, and now, the last but not least, this should come up hot. Yep. Okay, that was it. All we had was a wire popped out of one of those quick snappy connect things. I am a big fan of these quick connects. They work just great, especially for lighting, and I've used them now for outlets. And I think as long as you jam them in, they're really good. Trim them properly and jam them in all the way till you see they're clear on the one side, so you can see when they're all the way up to the back side. And as long as you've done that, I do not think they're coming out. So my bad, and everything's good. Well, there we go. The bench is ready to be loaded down with equipment. Got my static mat on. Got all the shelves ready to go. Okay, this should be the last bit. I'm pretty much done putting my test gear on my bench. I've used it for several days now. I pretty much have all the gear, but I was going to have some books up here. I haven't brought my books out from the house yet. So let's take a tour of what we have. I've been having a cold lately, so I have a hard time talking. As before, I have all my test leads, patch cables, oscilloscope probes hanging over there, and a couple of magnet strips and some other tools. Then of course my lamp that goes in a little hole I drilled over there. Let's see, starting from over here, we have my meters. Outplay meters. I got a Fluke 16, a Fluke 117, and a Macron. I can't pronounce it. It's Radio Shack brand Macronta. Someone else can pronounce it for me. Macronta. It's the first meter I got. My wife got it for me when we were still in college. Still use it though. Still like it. And then I have a clamp meter over here, and I got some 99% isopropyl alcohol, some wires and helping hand, my solder, my main soldering iron, which is the Heiko 936. I have a logic analyzer. Just keep it there because it's handy. Of my other Fluke, my Fluke 87, which right now is set up in this little gadget because we go like that. And my son and I have been doing his spelling words every night with Morse code. So I got this off of Craigslist and just hooked it up to my multimeter for the beeping I am going to build a circuit here. Actually, I got a circuit ready to go. I just haven't had the time to put it all and then get my meter back to being a meter again. But yeah, I found out that this Fluke 87 was the only thing fast enough to run this. These other meters over here, the continuity was not fast enough. They wouldn't work. So that's tells you just how good those Flukes are for continuity testing. They're real fast. Let's see. And over here, I have my bench vise. I got these magnets from Home Depot, and I keep all my I line up my screwdrivers on there, and I drill some holes from some of the main stuff I use all the time. I got another magnet up here, another magnet up here for more stuff. And you do have to keep these magnets away from your oscilloscopes because that will affect them. I know that this distance is fine. I tested from high frequencies signals and it was fine. But anything closer than that and it would start messing with the scope. But you know, if I were a professional, I wouldn't even allow magnets that close to anything. I'm just a hobbyist, so it's no big deal. We got basically just tweezers and some specialized tools. And then my wire strippers on this magnet, some needle nose pliers, my isolation transformer, which I use a lot when I'm working on 120 volts, my hot air rework station, which actually has the hot air wand as well as a second soldering iron. It's got a real nice thing. This comes out like this on this. This is called a Blackjack BK5050. I got it for like 99 bucks because they were getting rid of it at the Circuit Specialists. But what's nice is this comes out and then it drops in here, and then you can have your hands free to work with the board and the parts, and that's really nice. I like that touch that they added. Put that back. And let's see, let's go over here. We got my Tektronix Oscilloscope, the 2465, 300 megahertz. Got this off of Craigslist for 100 bucks. I was really happy with it. Came with 4 probes, 300 megahertz probes. Each of those probes are almost 350 bucks a piece. So I got 4 of them, and yet I only paid 100 bucks for the scope, and it works flawlessly. I just am very impressed with it. Then I got my BK Precision DDS signal function generator. I got that off of, actually I bought that at Granger. They were clearance, they're getting rid of them, they're going to a new model. And I got it for like 150 bucks. And up here I got another buy off of Craigslist, which is a LaCroix LA314H, a 470 megahertz oscilloscope. It came with a couple probes too. Has a little bit of burn in though, which is annoying. I do like it though. It works real nice for an analog scope, but it's just fun to play with it sometimes, especially if I'm doing anything in the higher ham radio stuff. Then my go-to scope is my Tektronix TDS 2012B. It's a color scope. It's really nice. It's really fast to use, but it's only 100 megahertz. But it's a real quality scope. Let's see, we'll go up here, and we've got a couple of Fluke bench meters. They actually came with this LaCroix, so they were free. Really, they were just in the box. They're not that great spec-wise though, and I don't know. I use them once in a while just for fun. So you have my microcurrent from EEV blog for measuring really. Basically, you can measure milliamps, microamps, and nanoamps with this without affecting your circuit, without having burden voltage problems. Go to EEV blog and check out his microcurrent. I really recommend it if you want to do such testing. And let's see, some breadboards here and breadboards here, and all my components in these bins here. Another calculator. Let's see. Come down here, I have a couple of cheap Circuit Specialists single range. It's basically a 3 volt, 4.5, 6, 7.5, 9, and 12 volt. It's a real noisy power supply, so you can't use it if noise is an issue. But they're handy just to power something project that isn't noise sensitive, or if you want to filter some of this noise, you have to. This is a really nice. Came from CircuitSpecialist.com as well. It's a CS13003X3. It's a real nice. It's got two outputs that go 130 each, 3 amps each, and it's got a dedicated 5 amps or 5 volts, 3 amps in the middle, and you can put these in parallel, or series, so you can either have more voltage or more current if you need to do that. And then it has some outputs down here. That's pretty sweet. And I think that's going to be pretty much it for the tour. Thanks for joining.